Lesson is on using slope-intercept form to graph. Now, in previous lessons, we talked about different ways to graph. One of them was to make an input-output table, find some x values and their corresponding y values, plot the point, and draw a line through them. Another way we learned how to graph is using intercepts. Put 0 in for x, find the y-intercept. Put 0 in for y, find the x-intercept. Plot those 2 points and draw a line through them. Now, I think the easiest one to use, though, is slope-intercept form. And what slope-intercept form is right here. Y equals mx plus b. Now let's talk about what this means. Let's use this example. Y equals 2x plus 3. If I wanted to make an input-output table to graph it, I would start maybe by putting, -2 in, and I go 2 times a -2, which is -4, plus 3, and I get a -1. Maybe I put 0 in. 2 times 0 is 0 plus 3 is 3. And maybe put 2 in. 2 times 2 is 4 plus 3 is 7. Okay? Now if I were to plot those points, they'd lie on this line right here. Let me show you that. A different color here so you could see. If I were to plot the points, I'd have -2, -1, which would be right here. I'd have the point 0, 3, and then I have the point 2, 7, which you can see that would fall on the line. Notice right here, at 3 on the y-axis, it's where it's hitting, or I'm sorry, the y-intercept is 3. Again, put 0 in for x, we get our y-intercept of 3. Now, let's find the slope. Using our slope formula, y2 minus y1 over x2 minus x1. I'm having with some points right here, so it doesn't matter which ones you use. I'm going to use 2, 7, and 0, 3. We're going to make these into points. So I'm just going to go the difference in my y's, 7 minus 3, over the difference in my x's, 2 minus 0. 7 minus 3 is 4, 2 minus 2 is 2, 4 divided by 2 is 2. So our slope is 2. Now let's analyze this for a second. Y equals 2x plus 3 was the formula, or was the equation we were using. We came up with our y-intercept, which is 3, and we came up with our slope, which is 2. Do you think it's coincidence that those numbers fall into slope-intercept form? No. If you look here, this m, the coefficient of x is always going to be the slope. Whatever number is being added on, that's always going to be the y-intercept. So we really didn't have to do any of this work down here. We can just look at this equation and say, oh, our coefficient of x is 2. That means 2 is the slope. We're adding on a 3. And that means that's our y-intercept. Okay? So slope-intercept form is going to save you a lot of work because it identifies the slope and y-intercept for you. Let's try an example. It says write the equation 3x plus 4y equals 8 in slope-intercept form. Slope-intercept form is y equals mx plus b. Then identify the slope and the y-intercept. Well, there was a reason we spent so much time solving for variables or writing things in function form, and this is the reason why. We want something solved for y. Okay, so if we want to solve for our y, let's get rid of our 3x first. Okay, again, we've done this before. Okay, these cancel out. I'm left with 4y equals 8 minus 3x, divide by 4, divide by 4. 4 divided by 4 is 1y. And then remember over here, we divide everything by 4. And I'm going to go keep change, and make this a -3 divided by 4. Just cleaning it up a little bit, 8 divided by 4 is 2. And then we're going to leave this as a -4/3. I'm sorry, -3/4 times x. Now if you look, that's a little bit different than this form. Okay? But it's addition, so we can have it in different order. It says identify the slope. Remember, our slope is always our coefficient of x. Okay, what number is attached to the x? So if you look at this equation here, what number is attached to the x? -3/4. And then what's our y-intercept? Remember, our y-intercept is whatever's going to be added on. Okay? y, what's ever being added on, wherever you want to look at it, okay? So what's being added on here? What constant? 2. So our y-intercept is 2. What this tells me is that the graph of this original equation is going to hit the y-axis at 2, and it has a negative slope, so it's going to be going down. It's going to be going down 3 and over 4. Okay? But again, once you put it in slope-intercept form, it makes it really easy to identify the slope and y-intercept. Now, why would you want to identify the slope and y-intercept? To help us graph. Okay? So look at this one. It says graph negative 2x plus y equals 5. Remember, we could make an input-output table. Pick 3 values for x, plug them in, see what you get for your y's. We could do intercept form. Put 0 in for x, solve for y, put 0 for y, solve for x. Or we could do slope-intercept form. Slope-intercept form, though, is y equals, so let's solve for y. If I'm solving for y, I have to get rid of the negative 2x. I get rid of the negative 2x by adding 2x to each side. That gives us 0, so I'm left with y equals 5 plus 2x. Now if we identify our slope and our y-intercept here is 5. Oops. And our slope equals 2. Remember, our slope is just what's the coefficient of x, just what's attached to the x, and our y-intercept is the number being like added or subtracted. Now, let's take this information and see how we can graph with it. Okay. Again, if we're looking at our coordinate plane here, this is our x-axis, this is our y-axis. I'm just going to take every one of these grid lines as being one unit. So what we do, our y-intercept is 5. Here's my y-axis, 1, 2, 3, 4, 5. Here's 5. So I plot that point. Our slope is 2. So we're going to apply our slope from this point. Now remember, slope is rise over run. So let's use this idea of our slope triangles again. From this point, if I rise 2 and I run 1, I end up right here. So from our y-intercept, we apply our slope. Rise 2, run 1. We have our triangle here. And basically, you can just draw a line through the points. A good line, not like the one I'm doing right now. Okay. But remember, we extend it off in both directions. We put arrows at the end. This line represents all the solutions of our original equation here, negative 2x plus y. Again, you start by plotting your y-intercept, which is 5. You apply your slope, rise 2, run 1, and then you draw a line through the points. If you had made an input-output table, even if you had done intercept form, you would have still gotten the same line. So once things are in slope-intercept form, you, again, plot your y-intercept and then apply your slope from that point using rise over run. And this is the quick way to graph using slope-intercept form.